There is a sound that German infantry on the Eastern Front learned to dread, and it was not the sound they expected. They knew the clatter of the T-34, the all-steel tracks ringing and grinding against the frozen ground, announcing a Soviet armored column from more than a mile away. But in 1944, on certain nights along certain sectors, they began to hear something different coming out of the dark. A high, urgent, mechanical scream, a sound that seemed to belong to an engine turning at impossible speed, rising and falling as the unseen vehicles maneuvered. It did not sound like a tank. It sounded like something between an airplane and a power saw, a relentless metallic wail that carried through the cold air and set men's nerves on edge. The Germans did not know what they were hearing, but the men who built the engine knew exactly. They called it the Screaming Jimmy. It was the sound of a General Motors two-stroke diesel turning over twice as fast as it actually was, the blower whining, the exhaust barking on every single revolution. And it was coming, on those Ukrainian nights, from a tank that should not have existed in Soviet service at all, a tank built in Michigan, powered by an engine designed for American city buses, shipped across 2 oceans and handed to the elite guards formations of the Red Army. It was the M4A2 Sherman, and the Soviets loved it, and they called it the MCHA. And at its heart were 2 ordinary truck engines bolted together side by side. This is the story of how the United States Army rejected one of the best engines it ever put in a tank, and how the rest of the world picked it up off the ground and drove it all the way to Berlin. To understand why anyone would couple 2 truck engines together to power a tank, you have to start with the same problem that haunted every American tank of the early war. The United States could build hulls, it could build turrets and guns and armor and tracks. What it could not do at the start of the war was build a proper tank engine, because it had never developed one. 2 decades of starvation budgets between the wars had left the Army with almost no tanks, and therefore no reason to fund the development of a dedicated tank power plant. When the war came and the tanks were suddenly needed by the thousands, the engine bays were, in a sense, empty. There was nothing purpose-built to put in them. The stopgap was the Wright Air 975, an air-cooled radial aircraft engine pressed into ground service, and it worked, but it created a crisis of its own. Every radial that went into a tank was a radial that did not go into an airplane, and in 1941, the Army Air Corps was expanding at a furious rate and wanted every aircraft engine it could get. The competition was brutal, and the tank program was losing it. The Ordnance Department needed alternative engines, and it needed them from sources that did not compete with aviation. So in 1941, it went out to American industry with a simple, desperate request: find us a tank engine. Use whatever you already have. And it turned, among others, to General Motors, which did not have a tank engine, but which had something almost as good, a compact, powerful, reliable diesel that it was already building by the thousands for buses and trucks and boats. The question GM's engineers asked themselves was not how to design a tank engine, it was how to make the engine they already had do the job. And the answer they arrived at was arithmetic.
The engine GM had was the Detroit Diesel 671, an inline 6-cylinder 2-stroke diesel that, in its military rating, produced about 225 horsepower. The tank needed something on the order of 375 to 450 horsepower. One engine was not enough. But the math was obvious, almost insultingly simple. If one 671 made 225 horsepower, then 2 of them made 450. So GM's engineers took 2 complete 671 engines, set them side by side, both turning the same direction, and geared their output shafts together at the front into a single transfer case that combined their power and sent it back to the tank's transmission as one unified stream. They called the result the 6046, and it was, in the most literal sense, 2 truck engines acting as one. This was not as crude as it sounds, and it was not as simple as it sounds either. Each of the 2 671 engines remained a complete independent engine with its own crankshaft, its own blower, its own cooling system, its own fuel injectors, and, crucially, its own clutch. This is an important point and one that the casual histories get wrong because they often say the two engines shared a common crankshaft. They did not. Each engine was whole and self-contained, and the two were joined only at the output where their power was combined. And that independence was not an accident. It was the source of the 6046's single most remarkable feature, a feature no other Sherman possessed. Because the two engines were separately clutchable, the crew could disconnect one of them. If one engine was damaged by enemy fire or failed mechanically, the driver could declutch it and keep moving on the surviving engine alone, at reduced power, but moving. A tank crew that took a hit to the engine compartment and would have been immobilized in any other Sherman could, in the M4A2, limp back to a repair depot or, in some cases, keep fighting on one engine. Tank crews in the field reported doing exactly this. Two engines meant redundancy, and redundancy in combat meant survival.
Now we have to slow down and explain how this 671 actually worked, because the engine GM doubled was a genuinely clever and unusual machine, and because understanding it is the difference between knowing that the 6046 worked and understanding why it screamed, why it was reliable, and why it was so different from the gasoline engines around it. The 671 was a two-stroke diesel, and the two-stroke part is where the cleverness and the difficulty both lived. Consider how an ordinary four-stroke engine works. The piston makes four separate travels for each power impulse. It goes down to draw in air, up to compress it, down again as combustion drives it, the power stroke, and up again to push out the exhaust. 4 strokes, 2 full revolutions of the crankshaft, 1 power impulse. A two-stroke does away with half of that. It fires on every single downstroke, a power impulse on every revolution, which theoretically doubles the power you can get from a given size of engine turning at a given speed. But this creates a fundamental problem. If the engine fires on every downstroke, there is no separate stroke left over to breathe in fresh air and no separate stroke to push out the burnt exhaust. The engine cannot inhale and exhale the way a four-stroke can. It cannot, in the language of engineers, naturally aspirate. It physically cannot draw its own air. So the 671 had to have its air forced into it, and this is what the blower was for. Mounted along the side of the engine was a roots-type blower, a pair of meshing lobes spun by gears off the crankshaft, the same kind of supercharger that hot rodders would later make famous sticking up through the hoods of drag cars. But on the 671, the blower was not there to add power in the way a hot rodder's blower is. It was there because the engine simply could not run without it. The blower took in air and pushed it under a slight pressure of a few pounds through passages cast into the engine block and into a row of ports, openings machined into the walls of each cylinder. As the piston traveled down past these ports, the pressurized air rushed in through the side of the cylinder, and this incoming air did two jobs at once. It filled the cylinder with the fresh charge needed for the next combustion, and as it rushed in, it physically swept the spent exhaust gases up and out ahead of it, scavenging the cylinder clean. The fresh air came in low through the wall ports, and the exhaust went out high through poppet valves in the cylinder head, valves worked by push rods and a camshaft exactly as in a four-stroke, but used here only to let the exhaust escape. Air in through the sides, exhaust out through the top. Engineers call this uniflow scavenging, and it is an elegant solution to the two-stroke diesel's fundamental inability to breathe on its own.
There were two more pieces of the 671 that made it what it was, and the first was the way it delivered its fuel. Most diesel engines of the era used a central injection pump that pressurized the fuel and sent it out through a spider's web of high-pressure steel lines to each cylinder. Those lines were a constant source of trouble, prone to cracking and leaking and failing under the relentless pulsing of the pressure. The 671 did away with them entirely. It used what GM called the unit injector, one for each cylinder, and the unit injector combined the high-pressure pump and the spray nozzle into a single device sitting right on top of the cylinder, worked by the same camshaft that operated the exhaust valves. The fuel was pressurized inside the injector body itself at the exact moment of injection, right where it was needed. There were no high-pressure lines running around the engine because there was nothing for them to connect. This eliminated an entire category of failure, and it was a piece of engineering that traced directly back to the obsessions of the man whose company had pioneered it. There was no spark plug, no distributor, no carburetor, no ignition system of any kind. The diesel fuel, sprayed into air that had been compressed to 16 times its original volume and heated by that compression to over 1,000 degrees, simply ignited itself. And the second thing, the thing the Germans heard in the dark, was the sound. Because the two-stroke fired on every revolution instead of every other one, it produced twice as many exhaust beats per second as a four-stroke turning at the same speed. To the ear, this made the engine sound as though it were spinning twice as fast as it actually was. Add the rising whine of the Roots blower, geared to spin faster as the engine sped up, and you got a distinctive, high-pitched, urgent mechanical scream. An engine loafing along at 2,000 revolutions per minute sounded like a gasoline engine screaming at 4,000. The men who worked with these engines, the bus drivers and the truckers and the sailors and the tank crews, gave them a nickname that stuck for the better part of a century. They called the whole family of Detroit two-stroke diesels the Screaming Jimmy, Jimmy being shorthand for GM and screaming for the noise that no one who ever heard it could forget. Every engine has a father, and the father of the 671 was one of the most prolific inventors in American history, a man whose fingerprints are on nearly everything that made the 20th century automobile possible. His name was Charles Franklin Kettering, and everyone called him Boss Ket. He was born in 1876 on a farm near Loudonville, Ohio, a farm boy who became an engineer, and over his career he would accumulate 186 patents. He invented the electric self-starter that ended the era of the hand crank and the broken wrists and the men killed by kickback. He developed the leaded gasoline that cured engine knock. He developed Freon, the refrigerant that made modern air conditioning possible. He ran the research laboratories of General Motors for nearly 3 decades, and in the later part of his career, he became obsessed with the diesel engine. The obsession had a famous trigger, and the trigger was a boat. Kettering bought diesel engines for his yacht so that he could spend time in the engine room studying them, taking them apart, understanding why the diesel cycle, which was so much more efficient than the gasoline engine, had never been made light and fast and compact enough for everyday use. The story goes that Alfred Sloan, the president of General Motors, walked into Kettering's laboratory one day and asked him why, given the diesel's efficiency, it was not more widely used. Kettering explained the technical obstacles, and Sloan, in a decision that would echo for decades, replied, "Very well, we are now in the diesel engine business. You tell us how the engine should run, and I will see that the manufacturing facilities are provided." Sloan would later say that in the matter of diesel engines at General Motors, Charles Kettering came very close to being the whole story. To get into the business, General Motors bought the Winton Engine Company of Cleveland in 1930, and Kettering put its engineers to work building the kind of diesel he envisioned, lighter and faster and more compact than the slow, massive, heavy diesels that powered ships and power stations. The first triumph was a big two-stroke that powered the streamlined Burlington Zephyr passenger train in 1934 and began the long death of the steam locomotive. The next step was to shrink that technology down into a compact, high-speed engine that could go into a truck or a bus or a boat. That engine became the Detroit Diesel Series 71, and its flagship was the 671. It entered production in 1938, and in that first year its engines went where Kettering had aimed them, into city buses and into boats, not into anything remotely military. Tuned for a city bus, the engine made about 165 horsepower. Tuned for the Navy, with the governor opened up, it made 225. Nobody in 1938 was thinking about tanks. That would come 3 years later when the world caught fire and the War Department came calling, and GM's engineers looked at their bus engine and did the arithmetic.
Let us be precise about what the finished 6046 actually was, because precision is where honesty begins. The complete engine was 12 cylinders, 2 banks of 6, 2-cycle, liquid-cooled, compression ignition. It displaced about 850 cubic inches, the sum of its 2 671s, each of which had a 4 1/4-inch bore and a 5-inch stroke. It had a compression ratio of 16:1, which is more than 2.5 times the compression of the R975 radial it competed with, and that high compression was the source of its efficiency. It produced 375 net horsepower and 410 gross, and 1,000 pound-feet of net torque, the twisting force that actually moved the heavy tank. And it weighed, complete and dry, 5,110 pounds, more than 2.5 tons, far heavier than the radial it replaced. That weight was the price of the diesel's virtues, and the virtues were real.
The 1,000-pound-feet of torque came on strong and low, which meant the M4A2 did not have to be revved hard the way the radial engine Shermans did to get moving. It pulled smoothly from low speeds, which made it better at the deliberate, grinding low-speed work that real combat demanded, climbing hills, crawling over obstacles, maneuvering carefully under fire, as opposed to the high-speed road marches that looked good in peacetime exercises. In trials, the M4A2 outperformed the standard radial engine Shermans in exactly this low-speed control. The diesel had its problems, especially early on. The twin air cleaners clogged and needed constant attention. Synchronizing the two clutches was tricky on the early tanks and wore them out. The fuel injectors gave trouble at first, but these were teething problems, and they were sorted out relatively early in production, with better injectors and better air cleaners and better clutches. What remained was a solid, torquey, efficient, durable tank engine. By the honest assessment of the people who know the Sherman best, it was one of the better engines the tank ever had, and the United States Army did not want it. The decision to reject the diesel Sherman came down to one man and one word, and the word was fuel. The man was Lieutenant General Jacob Devers, the chief of the Armored Force, the officer responsible for deciding how America's tanks would be powered and equipped. Devers looked at the M4A2, and he did not see an engine. He saw a logistical complication. The United States Army ran on gasoline. Its trucks ran on gasoline. Its Jeeps ran on gasoline. Its other Shermans, the radial-engined ones and the coming Ford V8 ones, ran on gasoline. The entire supply chain that fed the American war machine, the tankers and the depots and the jerrycans and the pipelines, was built around a single fuel. Adding diesel to that chain meant building a second parallel supply network with its own storage and its own delivery and its own depots, and accepting the constant risk that the wrong fuel would reach the wrong unit at the wrong moment. Devers was not willing to accept that, and from a pure logistics standpoint, he was probably right. The American supply system in the European theater was already the most complex logistical operation in human history, and the discipline of a single fuel was worth a great deal. So Devers made it policy. No diesel Shermans for the Army outside the continental United States. The M4A2 was relegated to stateside training where its fuel did not matter. The Army would fight with the gasoline Shermans. It was a defensible decision, a rational decision, and it had a strange and enormous consequence. It meant that one of the best Sherman engines, the reliable, torquey, efficient, harder-to-ignite diesel twin, was not going to be used in combat by the Army that built it. It was going to be given away. And the people it was given to wanted it very badly indeed. The Soviet Union ran on diesel. Its great tank, the T-34, was powered by the V2 diesel engine, and the entire Soviet armored supply system was built around diesel fuel. To the Red Army, a gasoline tank was the problem, not the solution. When the Soviets received early gasoline-powered Lend-Lease tanks, the M3 Lees, they used them but complained bitterly about the volatile fuel and the fire risk. So when the Americans offered the diesel M4A2 with an engine that burned the same fuel as the T-34, the Soviets embraced it. The diesel Sherman was the Sherman they wanted, and they asked for it specifically. The Soviet Tank Command requested that future Sherman deliveries be the diesel M4A2 and nothing else. The numbers are worth getting right because they're often repeated carelessly. According to American shipping records, something in the range of 4,000 M4A2 Shermans were shipped to the Soviet Union over the course of the war, the best documented figure being about 4,064 tanks, split between roughly 2,000 with the original 75mm gun and roughly 2,000 with the more powerful 76mm gun. But shipped is not the same as arrived. Of the tanks that left American ports, only about 3,600 actually reached the Soviet Union. The rest went to the bottom of the sea, sunk by German U-boats and aircraft on the brutal Arctic convoy route to Murmansk and Archangel, or lost on the longer, safer Pacific route to Vladivostok. One detail captures the whole grim arithmetic.
The Liberty ship Thomas Donaldson, part of an Arctic convoy, was torpedoed in March of 1945 within sight of the Soviet coast, just 20 miles from safety, carrying a load of the newest M4A2 Shermans. Decades later, divers would recover those tanks from the seabed, the diesel engines that had been built in Detroit to fight in Berlin, instead resting in the cold dark of the Arctic Ocean. The gun breakdown, incidentally, exists only in the American records. The Soviet receiving clerks wrote down every one of them simply as M4A2 and did not distinguish the guns, which is why any precise count of 75s versus 76s has to come from the paperwork on the American end. The Soviets gave the Sherman a name. They called it the Umcha, a nickname derived from the designation M4, rendered in Russian with the open figure 4 resembling a Cyrillic letter, a piece of soldiers' slang that became a term of genuine affection. And they did not consign the Umcha to second-line units. They gave it to their best, to the Guards formations, the elite of the Red Army, the spearhead units that had earned their designation through extreme heroism and that led the great offensives driving west toward Germany. The 1st Guards Mechanized Corps, the 3rd, the 9th, the 6th Guards Tank Army, these were not units receiving cast-off equipment. They were the tip of the Soviet spear, and they rode American Shermans. The reason the Soviets gave the Sherman to their best units rather than to their worst tells you how highly they valued it, and the accounts left behind by the men who crewed it read, even today, as something close to affectionate. The richest of these accounts comes from Dmitry Loza, a hero of the Soviet Union who commanded a battalion of Shermans in the 9th Guards Mechanized Corps and who left a detailed memoir of his war. Loza had 3 Shermans shot out from under him over the course of the fighting, and he drove the Umcha from Ukraine, through Romania and Hungary and into Austria, and later across the Gobi Desert against Japan. He praised the Sherman for things the T-34 did not offer. It was quieter, its rubber block tracks far less noisy than the ringing steel tracks of the T-34. It had better gun sights and better radios. It had an auxiliary power unit that could charge the batteries without running the main engines, so the crew did not have to fire up the engine and give away their position just to power the radio. The seats were comfortable, covered in a fine artificial leather that Loza's infantry would sometimes strip off to make boots, and he found it more reliable than the T-34, whose wartime build quality had collapsed under the pressure of desperate mass production. The Sherman was not a more advanced tank than the T-34, but it was a better-made one, and in the day-to-day reality of keeping a tank running, that mattered. Loza also told a story that captured the Sherman's one real vice, its high center of gravity, which made it prone to tipping on a sharp turn. One night in Hungary in December of 1944, his own tank tipped over on a turn. It should have been a disaster. Instead, it saved his life, because the 4 tanks that drove on ahead while his crew righted theirs drove straight into a German ambush and were destroyed. The Umcha that fell over was the Umcha that survived. And when the Soviets were offered an alternative, the M4A4 with its bizarre Chrysler 30-cylinder engine, they tested 2 of them, listened to the explanation of how to maintain 5 engines joined together, and refused. Too complicated, they said. They wanted the diesel twin and nothing else. 2 engines they understood, 5 they did not trust. M4A2 Shermans of the Guards tank armies fought their way into the streets of Vienna and Berlin in 1945, the bus engines from Detroit screaming through the rubble of the Reich. There was one other major combat user of the diesel Sherman, and the logic that brought them to it was the mirror image of the logic that drove the Army away. The United States Marine Corps fought in the Pacific, and the Marines came ashore in landing craft, and those landing craft were powered by the very same engine. The Higgins boats, the LCVPs that carried the assault waves onto the beaches, and the larger LCMs that brought the vehicles ran on Detroit Diesel 671 engines, the single version of the same engine that the 6046 doubled.
The numbers are staggering. Something on the order of 57,000 individual 671 engines went into American landing craft during the war, including roughly 19,000 in the Higgins boats alone. For a Marine division fighting on a Pacific island, this fuel commonality was a gift. A Marine division did not have a sprawling continental supply chain to draw on. It had what it could bring across the beach and what the Navy could land. If the tanks burned the same fuel as the boats that carried them, the logistical problem was cut in half. One fuel on the beachhead instead of two. And the diesel brought the same safety advantage that the Soviets valued. Diesel fuel has a higher flash point than gasoline. It does not ignite as readily when a tank is hit. In the close, vicious combat of the Pacific Islands, where the Sherman was used as a siege weapon, crawling forward at walking pace to blast Japanese bunkers and caves, while infantry sheltered behind its hull, a fuel that was less likely to erupt in flame when an anti-tank round came through was a fuel worth having. The Marine Shermans made their combat debut at Tarawa in November of 1943. 14 M4A2 mediums of a single company carried to the atoll in a new landing ship, the first Marine Corps medium tanks ever to go into action. From Tarawa, the Beazle Shermans went on to Saipan and Guam and Tinian and Peleliu and beyond, until the supply of 75mm M4A2s finally ran dry late in 1944, and the Marines, like the Army, transitioned to the gasoline Ford V8 tanks. It is worth pausing to lay out plainly why the diesel M4A2 was, by several measures, a better combat tank than the gasoline Shermans the Army preferred, because the Army's decision to reject it, while logistically sound, has obscured how good the vehicle actually was. The case rests on four advantages, and they were all real. The first was fire safety. Diesel's higher flash point made the M4A2 less likely to burn when penetrated, a difference that mattered enormously to the 5 men sitting inside a steel box that the enemy was trying to set alight. Soviet crews specifically noted that the MCHA was less prone to catch fire than their other tanks. The second advantage was mechanical simplicity, which sounds paradoxical for an engine that was 2 engines, but which was true at the level of the individual cylinder. A diesel has no ignition system at all. No spark plugs to foul, no distributor to crack, no ignition coils to fail, no carburetor to flood. The fuel ignites from compression alone. An entire category of failures that plagued gasoline engines simply did not exist on the diesel. And in the field, where reliability is everything, that simplicity translated directly into tanks that kept running. The third advantage was efficiency and range. The diesel's 16:1 compression ratio against the radial's 5.7:1 extracted far more energy from each gallon of fuel, giving the M4A2 better fuel economy and longer range on the same amount of fuel, which mattered on islands and steppes where every gallon had to be hauled forward at great cost. And the fourth advantage was the redundancy of the twin engines, the ability to lose one engine and keep moving on the other, a survivability margin no single-engine tank could match. 4 advantages, all genuine, and the Army gave them all away for the sake of a single fuel in the supply chain. From a logistics standpoint, it was the right call. From the standpoint of the tank itself, it meant the best engine went to everyone except the people who built it.
The wartime tank engine turned out to be a brief chapter in one of the longest production stories in the history of the internal combustion engine. The 671, the bus engine that GM doubled to make the 6046, simply refused to die. It had entered production in 1938, and it would remain in production until the summer of 1995. 57 years of continuous manufacture, finally retired not because it had become obsolete, but because tightening emissions standards at last favored 4-stroke designs. The engine that powered Sherman tanks and Higgins boats went on, after the war, to power tugboats and fishing vessels and generators and fire trucks and city buses and long-haul trucks and construction equipment on every continent. Detroit Diesel built more than 5 million engines over the years, more than 1 million of which are reportedly still running somewhere in the world today.
The screaming Jimmy became one of the most familiar mechanical sounds of the 20th century. The wartime production alone tells the story of American industrial scale. From around 9,000 engines in 1941, Detroit diesel ramped to nearly 58,000 Series 71 engines in 1943 alone, and over 100,000 GM diesels were built across the war. The 100,000th 671 was ceremonially handed to the Navy in 1944. Of the wartime engines, some 57,000 went into landing craft, around 22,000 into M4A2 Shermans as twin-packed 6046 units, 11,000 into M10 tank destroyers, and 4,000 into Canadian-built Valentine tanks bound for the Soviet Union. And after the war, the Soviets paid the engine the highest compliment one industry can pay another. They copied it. Soviet engineers reverse-engineered the 671 from Lend-Lease examples and produced their own versions, built at the Yaroslavl automobile plant, which powered Soviet heavy trucks for decades. The heavy trucks that carried Soviet missiles through the Cold War had in their engine rooms the descendants of the Detroit bus engine that Charles Kettering's team had created in the 1930s.
The lesson of the GM 6046 is a lesson about improvisation and about the strange paths that good engineering takes. The engine was never designed to be a tank engine. It was designed to be a bus engine, a truck engine, a boat engine, the product of one inventor's decades-long obsession with making the diesel cycle light and fast and compact. When the war created a sudden, desperate need for tank engines, GM did not have time to design one from scratch, so it reached for what it had. And what it had was the 671, and the only way to make the 671 powerful enough was to use two of them. The 6046 was not an elegant solution. It was a heavy, complicated, doubled-up expedient, two engines doing the work of one. But it worked, and it worked superbly, and it embodied exactly the kind of pragmatic, available-now improvisation that defined the American industrial war effort. And it carries a deeper irony, the irony that runs through the whole story. The army that built the best engine rejected it for reasons that were sound and gave it to everyone else. And everyone else, the Soviets and the Marines and the British and the French and the Poles, fought in it and loved it and drove it from the steppes of Ukraine to the beaches of the Pacific to the streets of Berlin. The engine never knew what country it was fighting for. It had been designed by an Ohio farm boy for American city buses, built from two truck motors bolted together in a Michigan factory, installed in a tank, shipped across oceans, and sent into battle by armies that were not the one that built it. It just ran. It started every morning. It pulled the tank all day, and when the tank was hit, it kept running on one engine when the other was dead. And it did not catch fire as readily as the gasoline tanks did. That was what its crews asked of it, and that was what it delivered.
In a war decided by what worked was two bus engines bolted together. The GM 6046 was not the engine anyone set out to build. It was the engine that arithmetic produced when a nation that had never made a tank engine suddenly needed one and reached for the only suitable thing it already had. Two Detroit diesel 671s, the screaming two-stroke diesels designed for city buses and fishing boats, set side by side and geared into one, making 375 horsepower and 1,000 pound-feet of torque. Heavy and complicated and utterly reliable, with the strange and priceless ability to lose half of itself and keep going. The United States Army rejected it, and the Army was not wrong to do so, because a single fuel was worth more to its vast supply chain than the virtues of any one engine. But the rejection meant that the best Sherman engine became the world's Sherman engine. It went to the Soviets, who put it in their Guards formations and drove it to Berlin and called it the MCHA and loved it. It went to the Marines, whose landing craft burned the same diesel and who took it across the Pacific island by island. It went to the British and the French and the Poles. The diesel Sherman fought on every front of the war, except the one where the American Army was fighting, because the American Army had decided it did not want it. In a war fought between industrial systems, the system that could take a bus engine and turn it into a tank engine in a matter of months by the simple expedient of using two of them was a system flexible enough to win. The Germans built beautiful, purpose-designed tank engines, the Maybachs, technically superior, produced in the thousands. The Americans built a doubled-up bus motor and produced it in all its forms in the hundreds of thousands. The Maybach was the better engine. The 6046 was the Moore engine, and it was everywhere, and it ran. It was the engine the Army rejected and the world embraced. Two of something that already existed, joined together not by inspiration but by necessity, and sent to war in the hands of soldiers who did not care how it had been designed, only that it started every morning and ran all day, and screamed its high mechanical scream and did not burn when somebody shot at it. That was enough. In a war decided by what kept running, the bus engine kept running, on two-cylinder banks or on one, from Detroit to Berlin. And that, in the end, was more than enough.